Welcome to day 2 of ARM DevSummit. Day 1 was quite a packed day for keynote sessions. I hope you found both the conversations and presentations useful for you. All of them are now available on demand to register attendees at armdevsummit.com. Here's a quick recap of what you heard on day 1. Our CEO, Simon Segars, showed how ARM technology is helping in the fight against COVID-19, with Darwin AI leveraging ARM's AI platform to rapidly develop a diagnostic system for doctors. Some really cool stuff. Our own Mark Hambleton gave you an overview of the initiatives to make developing on ARM easier. Mark also highlighted some of the challenges we're facing, like over-the-air upgrades and lifetime product support, important issues as we move towards a world connected by 1 trillion devices. Our infrastructure business leader, Chris Berge, hosted a roundtable on how ARM is transforming cloud economics with executives from AWS, SmugMug, and Honeycomb.io. We welcome Diane Marsh, who leads device and content security at Netflix. Diane shared details on the work that her team is doing with global device partners, providing a secure transit of video content across any device. And I was fortunate enough to host a fireside chat with my current boss, Simon, and my former boss, NVIDIA CEO, Jensen Huang. And speaking of NVIDIA and their agreement to purchase ARM from SoftBank, it would not be accurate for me to stand up here and tell you that nothing will change for ARM as part of NVIDIA, because it's the potential of doing even more which really excite me. Now together, we have a unique opportunity to set the course and future for the computing and age of AI. There'll be countless benefits for both our hardware and software ecosystem. Now I'm also excited and confident about what won't change, such as our strategies and roadmaps for creating new growth opportunities for our partners, and our successful 30-year-old business model that has resulted in the establishment of the world's largest computing ecosystem. An ecosystem that has helped make ARM the most pervasive compute architecture in the world. The ARM architecture is unlike anything else. It scales from the world's #1 supercomputer down to the tiniest power-constrained connected devices. And so why the future is being developed on ARM. Just look at the unprecedented pace of ARM chip shipments on this chart. I'd like to just take a moment here and thank our silicon partners who have shipped 180 billion ARM-based chips over the past 30 years. A staggering number in of itself. But what's even more staggering is what our partners have done over the past 5 years in shipping more than 100 billion chips. So if you've never developed an ARM before, expect that to change very soon. Because the billions of ARM chips shipped every year reflect our insatiable need for data. ARM will be everywhere data happens. Because of that, we have a unique responsibility and opportunity ahead. Driven by the growth of IoT, 5G networks, and the age of AI, it means we need to do more. Because not only is the pace of compute adoption accelerating, the evolution of compute requirements is as well. One thing that we believe will never change is the need for more and more CPU performance. Over the past 5 years, we've seen our strengthened investment in CPU performance pay off. These charts here tell the story. But as we move more and more into the age of AI and more complex workloads, annual double-digit CPU gains alone won't be enough. We're evolving our design methodology to go beyond raw CPU performance to impact system design, utilizing use case-driven system solutions. A key differentiator of this new way of designing IP is analyzing existing and emerging real-world use cases, breaking them down by computational building blocks in individual jobs. For example, we've developed a system-level simulator to develop and capture system-wide power, performance, and memory metrics when running key use cases. This is really important. Some of these key use cases include AI video content, such as face and object recognition and augmented reality, 8K video streaming under 120 frames per second, VR, AAA game titles. These are some examples of a unique and innovative design platform to address the evolving needs of complex systems that we refer to as total compute. Total compute has 3 foundational elements. System-level performance that looks at each individual compute function. Security, a grounds-up approach to designing and underlying security and content protection. In our next presentation, Paul Williamson, our leader of the client business, will tell you more about some of the new security features such as memory tagging extensions. But performance and security are only meaningful with common developer tools and a frictionless development experience. So today, I'm going to focus on this third very important component of total compute, developer access. We're making hardware performance more accessible for you, the developer. Total compute both accelerates and amplifies our developer ecosystem support, along with investments in software tools, which are critical to the total compute experience. Now, we're confident in our investments in developer access will make total compute the platform of choice for developers. This is why we're applying total compute design principles across our entire IP portfolio. To improve efficiency, performance, and the overall user experience, we are optimizing for both hardware and software workloads. In turn, we'll offer software frameworks across all markets and applications. We feel this is a really important step. The overarching objective for developers is to ensure that ARM IP solutions are the easiest and lowest risk options to deploy their applications. Now, we will do this by focusing on 4 fundamental aspects of the developer experience. A common platform for developers, where IP, firmware, software, operating systems, and tools work together seamlessly. We can put more control of your software performance in your hands through a suite of performance analysis tools designed to maximize performance. Your development experience in ARM should be a frictionless one through one goal: it should just work. Now, of course, you're going to need hardware to develop on. Entering the era of total compute, there must be developer board coverage across all markets. And we're collaborating with our hardware ecosystem to ensure that this happens. A common tool chain across all our IP is one of the many things that makes total compute unique. Frameworks for programming, debugging, and analyzing across the CPU, GPU, and NPU. We're ensuring that there's broad support for total compute technologies through collaborations with our third-party tool developers and ISV. And if there are tool chain gaps in our ecosystem, we'll address them ourselves. Again, it's all about identifying ways to improve the usability and simplicity to ensure a seamless developer experience. One example of how we're doing this is through performance analysis tools. Through Total Compute, developers can now conduct full system performance analysis for multiple workloads with a single tool suite, which includes Performance Advisor for analysis of how different workloads perform across all the SoC compute functions and identify bottlenecks. ARM-NN gives you a common API maximizing ML programmability across all ARM IP. This will enable ML performance uplift across all the compute functions. Now, ARM-NN is open source. We donated this in 2018 to the Linaro ML initiative. Now, with the ARM compute library, developers can accelerate CPU and GPU performance through things like Neon, OpenCL, GLES. By consolidating all these tools into a single suite means for you, the developer, there are fewer tools, and you can make life much easier, while putting more control and performance in your hands. Now, however, to do any of what I just discussed, having the right hardware to develop on is really key. What you see on the slide is just a sampling of the hundreds of ARM developer boards in the market today. For Total Compute, we've been working with our hardware ecosystem to ensure that we have the same coverage. It will be even more critical to bring market purpose-built boards available for specific use cases such as voice, object recognition, robotics, ML, video decoding, cloud workloads, and automotive. All of our ongoing developer initiatives have been done with a simple goal in mind: it should just work. We're focusing on ensuring frictionless development on ARM from sensors to cloud infrastructure. Now, today, the majority of ML workloads occur in the cloud. But the move to on-device ML, it's inevitable. We're investing in developer initiatives to enable more on-device ML opportunities, such as the work that ARM has been doing with Facebook on PyTorch. We've been working with Facebook to make it easy for developers to create optimal and portable ML applications for smartphones on ARM CPUs and GPUs. It's an ongoing collaboration which will target new processors and techniques as they become available. Following my keynote, Paul will dig a little bit deeper into developer initiatives on smartphones and other client devices. And going further down the stack, ARM is enabling ML on the tiniest devices, where their recently launched embedded ML solution comprised of the Cortex M55 processor and the Ethos U55 micro-neural processor. Again, making it easier for developers to bring these complex ML workloads to these constrained devices. Developers can now develop for both processors on a unified Cortex-M toolchain. Now, as autonomous systems move more and more towards software-defined functionality, we're accelerating the development of software to fully realize the benefits of our latest IP. One of the ways we're doing this is through initiatives such as Project Cassini, which is aimed at laying the foundation for the adoption of cloud-native software paradigms across the entirety of edge computing. Tomorrow, Dipti Vachani will kick off day 3 and share more details on our IoT and automotive developer activities. Dipti will then be followed by Chris Berge, who will provide details of our software ecosystem efforts for network infrastructure and cloud environments. Project Cassini is also an essential developer program for the deployment of ARM Neoverse, which is our complete secure infrastructure platform. Chris will share several new updates about our efforts to make Neoverse the #1 platform for cloud-native software from edge to cloud infrastructure. Now, to help pave the way for wider deployment of ARM solutions, we've also evolved our business model to enable our partners to have increased access to ARM IP. This is ARM Flexible Access. It will give the Silicon partners greater access to ARM IP, tools, services, to more partners than ever. It benefits both the hardware and software ecosystems. Our Silicon partners can now experiment with more ARM IP without significant capital investment. Everything needed for designing purpose-built SoC solutions. More than 60 partners signed up in the first year of the program alone. We've had adoption by academic researchers and government agencies. More than 30 first-time ARM partners, the majority of those being early-stage startups. One of those first-time ARM partners is Zortec, a French startup developing new intelligent footwear technology. They've developed a chip that uses AI algorithms embedded into shoes. Now, this can detect bone malformations, monitor diseases like Parkinson or diabetes, detect fatigue or injury risk. So here's Zortec CEO Karim Umnia to tell you more about their experience using ARM Flexible Access.
Zortec is specialized in smart footwear, means we transform shoes into smart shoes with our platform and technology. Our vision is a smart shoe must be a product that can really help you to monitor your life, to reduce fatigue or to detect fatigue, reduce injury risk, detect disease, improve your performances. Flexible access is a very interesting tool and method for us, especially for startup like us, because we are able to start working and developing before having the product in the market. Otherwise, we need to invest a lot of time and money investing in IP without getting any returns. So it's a perfect solution for a company like Zortec, or I think for any company, but especially for startups like us. We are always interested in the new technology that ARM is able to bring in terms of AI or microprocessing. For us, it's a key for our technology and platform. The fact that ARM came up with this new solution, a new offer, it was a game changer in our decision.
Thank you, Karim. In 2021, ARM will introduce its next generation CPU architecture. Now, this will usher in a new area of computing as it represents a fundamental shift from microarchitecture to system architecture. Partners can pack more fundamental IP blocks than ever before, working together efficiently on a single piece of silicon. Security and AI will be as important as general purpose computing. And of course, all the work we're doing to make life easier for ARM developers, will apply. Now, I've just scratched the surface here today, and throughout the rest of the event, our business leaders and technical experts will go into more in depth on these topics. But to recap, we're evolving to case-by-case driven design paradigm to enable a more symbiotic hardware and software relationship. We're investing in total compute for all markets, improving the developer experience by bringing the IP, firmware, software, operating system, and tools together. Through ease of use performance improvements and ARM engagement, we're confident that total compute will provide incredible value to our partners in the wider developer ecosystem. And recently, we've announced that we have strengthened our focus on expanding our IP business, so expect to hear more from us on ways that we're working to make life easier for developers. But in the meantime, tell us what else we can do to enable your ideas and innovation. Thank you for listening today and attending ARM DevSummit. I'll now turn things over to Paul Williamson.
Hello, I'm Paul Williamson, and I lead the group in ARM focused on mobile and consumer computing. And welcome to ARM's first official Dev Summit. I'm excited to be here with you from one of the thousands of platforms out there that you can leverage to build a new reality. I've always been fascinated by compute devices from my earliest experiences of programming breakout games on an Acorn Atom. We're in the midst of a journey in the way that we develop computing architectures. We're moving from thinking in terms of cores and CPUs to form factors and user experiences, a holistic approach which will unlock new capabilities and build tomorrow's applications and solutions. I'd like to thank you, the software and hardware developers who are at the core of what was once an inconceivable success. Industry innovation has produced smarter, smaller, and more efficient devices. And together, ARM, the ecosystem, and developers have transformed mobile from a simple utility to the most powerful, pervasive device that consumers hold in their hands. We're experiencing a more expansive and enriched world because of your daring ingenuity. But don't just take my word for it. Let's have a listen to some people who have also recognized the potential in mobile.
I'm John Romero, and I'm a video game designer. I'm a co-creator of the first-person shooter. I created games such as Wolfenstein 3D, the Doom series, and Quake. In the 20 years that I've been developing mobile games, the biggest changes that I've seen are definitely increased CPU, more memory. Mobile devices are so fast nowadays, we don't have to worry about whether the game will be fast enough on the device. We just need to worry that the design will take advantage of the device.
Most people don't think of it, but the smartphone in your pocket today, in the hands of you or in the hands of a child in Africa, empowers you with better communications technology than a head of state had 25 years ago. So the tools to change the world are now in everybody's hands. And if you think of these tools as conduits to unconstrained imagination, they provide for us the possibility of radically extending our reach, radically expanding the repository of what we can do, the dent that we can make in the universe.
So here I am, back in the real world. Now, mobile development has come a really long way. At the launch of app stores, there were only 500 applications, and we now live in a world of 8.9 million apps and 204 billion downloads every year. As you may have heard already, mobile developers is already a huge community of 13 million people. And this means that mobile is now the primary target for the majority of software developers worldwide. But we're in the midst of a change, a transition to 64-bit. Around 60% of the apps are already available as a 64-bit version. Leading app stores are driving a transition to 64-bit. But why are they moving? Well, the answer is better baseline performance. 64-bit can add as much as 20% in some workloads. In game development, we see that 64-bit provides an overall frame rate uplift ranging from 9.5 to 16.7%. Now that is a huge lift in a world that's moving to 120 frames per second content. It's in the range of a generation of GPU improvement that can be unlocked just by compiling your application to 64-bit. Now, from a performance perspective in the platform, we're building on that transition to 64-bit. And from 2022, our big cores will be 64-bit only. So the innovations of mobile software developers reach well beyond the smartphone. The user experience of the smartphone is now expected in other established markets, from your TV to your smart home devices to reshaping our expectations of what a laptop can be. The smartphone experience is even shaping the car and industrial applications. ARM technology is at the center of that incredible evolution, but it'll also be the basis of future platforms. So let's have a look at Pokemon Go. Now, we've long passed the peak of excitement in 2016 around the app launch, but I still love to play this with my kids. And Niantic has defined a new community of augmented reality gamers that have delivered the business a lifetime revenue of $3 billion. Now, the team at Niantic continue to create really compelling AR experiences, but they are pushing at the limits of the performance and driving the requirements of the hardware in every device. And it is the smartphone and mobile developers who are shaping new AR and VR experiences. As a result, it's going to be the smartphone platform which is going to provide the technology for the new form factors and devices which will shape our future. So, smartphone has a huge momentum as a developer platform, and it's expanding in its influence. But we've got a tough job ahead of us to keep pace with that ever-increasing innovation. Tomorrow's not going to be like today. A collision of technology challenges across process, Moore's law, the emergence of AI and machine learning, the scale of data and app complexity. It's going to require us to change and adapt. So at Arm, we're committed to a new strategy, one we launched last year. Total Compute is our transformative approach for designing computing solutions driven by next-generation user experiences. We believe that breakthrough performance is achieved through transcending the boundaries of cores and technologies, thinking of the system as an organic whole rather than the individual elements within that system. Total Compute is centered on three key principles: performance of the system, better developer access to that performance, and above all, security for both the consumer and the developer. Let me show you what we've achieved in recent years and give you a hint of where we're going next. As you can see, our CPU performance over the last few years has grown by 2.5 times from Cortex-A73 through to Cortex-A78. Today I can give you a hint of what's coming next. In our next 2 generations of performance CPU, these are going to be codenamed Matterhorn and Makalu. In these, we will continue to grow by yet another 30%. Now, I want to talk about how we make this performance available to developers. At Arm, we've had a continual focus on performance analysis because this allows developers to understand how workloads function across the different technologies within the system, and it identifies where bottlenecks can occur. Arm Mobile Studio now includes Performance Advisor. This provides you with clear visual feedback on the utilization of the CPU, the GPU, and now the NPU. Now, this is critical in the world of total compute, where workloads will execute across multiple compute domains. Also, with the increasing importance of machine learning and inference workloads, our tools now analyze how your neural network is being executed layer by layer to support you to tune the code or the model and to make optimum use of the system. We're also integrating that expertise with our ecosystem partners like Unity and Google, who provide tools to maximize gaming and AI performance. So, to tell you about how to make use of this performance and deploy your ideas on as many platforms as possible, I'm really pleased to introduce Ralph Howitt.
Unity is the world's leading platform for creating and operating real-time 3D content. And together with Arm, we've been focusing on performance, developer access, and security as some of the major focus points of our partnership. Today, I'm going to talk you through 3 things. First, I'm going to talk you through developer access. Second, I'm going to talk you to about our transition to ARM64. And third, I'm going to talk about our compiler tech Burst and how that impacts Arm platforms. So let me start with developer access. The Unity Distribution Portal, or as we refer to it, UDP. The competition in today's mobile market is fierce. To succeed, you need to get your game in front of as many as potential game players as possible. Now, Google Play is the dominant mobile game market on Android, and many developers start and finish their games releases with just this platform, either because they're unaware of other app stores or because they don't think they have the resources to sign up, track, and redeploy to all of them. We've created a largely self-serve dashboard that anyone, even a solo developer, can use to share my games more widely. To give your game maximum reach, it's important to address local audiences individually. Each market has its own legal framework, its own currency and audience needs, and understanding and meeting these requirements can be a huge headache. UDP solved this problem in a single hub. Now, There's no such thing as too much visibility for content creators. The Unity distribution portal for games works at every stage of their life cycle. By gaining maximum visibility for your game, tracking its performance from launch day onwards, and controlling all facets of your channel distribution with the UDP console, you'll have stronger insights about where to take your game next. To date, over 400 studios are already using UDP to boost their sales and reach a wider audience. Now that's about reach, that's about deployment, but where you reach audiences and on which hardware you reach them is equally important for the outcome of your game. So I'm going to talk about ARM64. Now at Unity, we're seeing an increase in user adoption of ARM64, and we're seeing getting over that inflection point. The point at which there's critical market mass and actually for us to switch over to primarily switch the default on ARM64. Now we've seen a tripling of ARM64 adoption, and Unity is ready for ARM64 today. With Unity 19.4 LTS, our long-term supported version of Unity, we now default to 64-bit on new projects. 80% of new builds made with Unity are targeting ARM64. Now, this is a continued area of collaboration together with ARM, where we focus on the overall performance improvements, battery performance improvement, and reduced binary sizes that we can establish through our work on ARM64. Now, as we keep on collaborating into the future together with ARM, I want to talk about Burst. Burst is our custom compiler technology that we're collaborating on, which enables Unity developers to get the most out of ARM hardware. It exploits parallelism and multi-core systems fitting well on the increased core count mobile world targets. Burst compiled code is able to compute frames with higher number of elements faster, allowing for better performance, less thermal throttling, lower battery consumption, and in the end, more engaging content. This demo that we're showing you right now shows a 2x performance improvement overall in both scene simulation and rendering, with reduced thermal throttling and a more stable frame rate, which is what we've primarily have focused on. Now, as we continue benchmarking and working together with ARM and making sure we produce the optimal code, we'll continue seeing greater perf in real-world applications. Now, lastly, through our partnership with ARM, we'll continue our focus on performance, security, and ensuring the success for as many Unity developers as possible across ARM-powered platforms. Thank you, and thank you for having me.
Thanks, Ralph. I'm so pleased that our partnership is supporting developers with our objective of providing performance by default. So finally, let me address the key underpinning aspect of total compute that's vital for all of us. This one's really important to me. Security is essential to build trust in applications, services, and the devices that are designed for tomorrow. We can all only succeed with continued progress in security. And the trend towards confidential compute is going to require ongoing innovation from all of us. Confidential compute is a way to describe the evolution of secure computing as we aim to make all aspects of this ecosystem less vulnerable to attack. For ARM, confidential compute covers everything from the architecture through application software, all the way to the services that you will use, offering defense in depth throughout. In our first generation of total compute and in our Matterhorn generation of CPUs, we're introducing a range of improved security features. So let me tell you about the first. We're introducing a major new innovative security feature called Memory Tagging Extensions, or MTE. This is going to tighten security vulnerabilities that can occur in memory subsystems. Now, memory safety bugs are the single largest category of hacker attacks. Put simply, MTE is going to make detecting memory safety violations easier and more efficient for every software developer in the ecosystem. Silicon vendors are going to be able to ensure that the software developed to support their SoC can address memory safety bugs before they provide their hardware to the OEM. For a device manufacturer, MTE helps them detect the additional memory safety bugs before the devices go to mass production. So once in the market, OS vendors and application developers can use MTE-enabled devices to find buffer overflows and heap corruption in their code. Developers have access to code checking tools like HWA-SAN or Hardware Assisted Address Sanitizer available in Android. MTE has proven benefits to the breadth of C and C++ code in devices. But MTE is likely to bring even greater value into the ecosystem in the future. For example, we're already seeing the unique applications of MTE in research where there are many benefits to be found in languages like JavaScript. So, MTE supports a scalable approach to security for a minimal performance cost. And that means developers can be really confident to use this tool to capture vulnerabilities of their application in the field and before their devices ship. MTE will be available in our Matterhorn generation of CPU, and it's aligned with the deployment of tagged pointers announced in Android 11. So let's get back to the future. What happens when you connect the power of mobility to a truly immersive platform? With all this work, we're building capabilities that will enable you to innovate and build the next generation of consumer experience. So let me tell you about one company who's working on a disruptive technology that could change the future for all of our experiences. A Silicon Valley-based startup called Mojo has developed the Mojo Lens. It projects real-time data directly onto your field of vision through a contact lens that you wear in your eye. Just imagine the possibilities of this. People suffering from acute visual impairment could have their vision augmented with the ability to see obstacles and to assist them in living a much richer life. But perhaps some of the more mundane and personal examples are interesting too. For me, imagine it being able to support you in your favorite sport, tracking your game as you play, or going on a foreign adventure and having the ability to navigate or have real-time translation overlaid on your vision. Mojo have already built working prototypes with dynamic content, and they're working to enhance the platform and integrate computer vision and eye tracking capabilities. Just imagine the possibilities when we can fuse the future of an innovative display technology like this with the imagination of developers. Total Compute delivers developer-accessible performance and security for our ecosystem. It's now down to you, the creators, to embrace that performance. Together, we can engineer our own new reality. Thank you.
Hi, my name is Arun Kishan. I run development of base operating systems technology at Microsoft. Thank you for giving me the opportunity today to speak about Microsoft's role in expanding the ARM ecosystem. Our industry is going through a fundamental transformation as it pivots towards a focus on the intelligent edge and intelligent cloud. As we embark on this transformational journey, we see an increasing number of edge devices leverage the power of ubiquitous cloud computing to enable scenarios that weren't possible a mere 5 years ago. There's no doubt that the ARM ecosystem plays a pivotal role in enabling the intelligent edge via billions of IoT devices. At the same time, we see the ARM ecosystem expanding to encompass everything from enabling new experiences on PCs to powering the next generation of cloud computing platforms. Microsoft has played and continues to play a key role in this transformation. Over the past few years, Microsoft has invested in building the operating system and developer platform to realize the full potential of ARM technology in each of these key areas: PCs, IoT devices, and the cloud. With respect to PCs, Microsoft launched the initiative called Always Connected PCs back in 2017. And since then, we have collaborated with our PC OEM partners to build and ship innovative PCs that run the full Windows 10 operating system, providing beyond all-day battery life, offering seamless LTE connectivity, enabling thin and fanless hardware designs, and delivering an instant-on experience that is typically found only on mobile devices. All of these ARM-based PCs are powered by Qualcomm Snapdragon System-on-Chips, or SoCs, that offer industry-leading performance, security, and connectivity with ultra-efficient power management capabilities. These PCs run the full Windows operating system that our users expect from Microsoft. It includes all inbox experiences and apps that users care about the most as they seamlessly transition between various facets of their daily lives. These include apps from our store, as well as the large ecosystem of Win32 applications. Thanks to the ultra-efficient ARM processors and key optimizations in the Windows operating system, these PCs offer beyond all-day battery life. By enlightening the core operating system to leverage key capabilities of the ARM architecture, such as big little cores and low-power standby, ARM PCs are able to deliver more than 24 hours of local video playback, over a month in standby mode, and multiple days of battery life when carrying out normal day-to-day work. These PCs also offer LTE connectivity from day one via physical SIM or eSIM capabilities that allow our users to choose the mobile operator of their choice to get securely connected to the internet within minutes. Given the current environment and looking forward to the future where employees and students will desire to work from anywhere, these PCs provide seamless access to a secure internet connection via LTE and in the future via 5G as well. Here, I have the Microsoft Surface Pro X. As you can see, it's an unbelievably thin and light, fanless design in a 2-in-1 form factor with a kickstand, keyboard, and pen. It is powered by the Microsoft SQ1 SoC that was developed with Qualcomm. The SQ1 is the first 3 GHz ARM processor. Compared to a mobile SoC, it has twice the caches and significantly enhanced GPU, more I/O in terms of PCI Express and USB, and twice the DRAM bandwidth. Yet, it still retains the top benefits of a mobile SoC. It has low-power architecture, integrated LTE, high-end performance DSP and vector engines for AI, and efficient AV processing. In addition, this was the first Windows PC built on the cutting-edge 7nm process. This device is also part of our Secured Core PC initiative, which means it has key OS features on by default. These include security features like device guard, virtualization-based security, hypervisor-based code integrity, and more. In fact, this was the only Surface PC that hit the Secured Core bar in 2019. When it comes to the manageability of these devices, all of these devices support modern deployment and management solutions from Microsoft. For example, these devices can be deployed using Windows Autopilot and can be managed using Microsoft Intune. In fact, IT admins can even use Intune to manage firmware on these devices by using Device Firmware Configuration Interface, or DFCI. These devices can also run industry-leading security protection solutions from Microsoft, such as Microsoft Defender Advanced Threat Protection, or ATP. In addition to Surface, we are actively collaborating with our close OEM partners such as Samsung, Lenovo, Acer, and HP. Samsung has an incredible Galaxy Book S LTE PC that's a full-featured laptop in a super thin and light design. Lenovo recently announced the world's first 5G PC running on the Qualcomm Snapdragon 8CX processor powered by Windows. We are extremely excited to see the arrival of the first 5G-capable devices powered by Windows. We're also excited to partner with HP and Acer, who have both had an incredible history of creating world-class devices. In particular, we're excited to see Acer announce their adoption of the newest Qualcomm Snapdragon 8CX Gen 2 in the new Spin 7, which will also be a 5G-capable device. Over the course of this journey, we have collaborated very closely with Qualcomm. While our first efforts were built on mobile-first SoCs, we have worked with Qualcomm to develop custom SoCs that are optimized for PC use, like the 8CX and the SQ1 we just discussed, which feature amazing compute and graphical performance, but still preserve the best attributes of the ARM platform. We are looking forward to our continued partnership with Qualcomm and the ARM ecosystem as we continue to evolve and innovate in this space. Now, as we talk about our transformational journey from the intelligent edge to the cloud, it's no surprise that IoT plays a key role. As per the IDC, there will be 80 billion connected things by 2025, and Microsoft is building a suite of solutions to help realize this vision. Our Windows IoT platform provides the foundation for intelligent edge devices. In scenarios where there are stringent resource requirements, we offer the Windows IoT Core OS. At the same time, we also offer the richer Windows IoT Enterprise, where the full power of the Win32 ecosystem is available. The Windows IoT family is built on the same foundation as Windows 10, which is running on over 1 billion devices worldwide. Our IoT offerings provide enterprise-grade security, manageability, and support that our customers have come to expect from Microsoft. Given it's built on the full power of Windows 10, IoT partners can quickly take advantage of advanced features like artificial intelligence and machine learning while creating better end-user experiences for the natural user interface. Furthermore, the security features that keep Windows safe, such as BitLocker, Secure Boot, and Device Guard, are also available on Windows IoT platforms. Microsoft currently supports Windows IoT on the Qualcomm Snapdragon 850 and the NXP IMX8M processors. Earlier this year, at Build 2020, we showed the Asus Pico ITX single-board computer powered by a NXP IMX8M processor running on the Windows 10 IoT Core OS. This particular platform from Asus is deployment ready, and we're very excited to see what IoT scenarios this will help enable. In order to enable the ecosystem to realize the vision of billions of connected things in the near future, we are actively working towards ensuring that our ecosystem partners can focus on creating unique and differentiated experiences and products rather than spending resources on bringing up the software and OS stack. To that end, Microsoft is collaborating with ARM on the ARM System Ready certification program to be the foundation for building silicon that works seamlessly with the Windows IoT family. Completing our journey to the intelligent cloud, we have also partnered with ARM to ensure that any ARM-based servers that are certified under the server-based system architecture and the server-based boot requirement portions of System Ready SR can successfully boot Windows, bringing them one step closer to enabling deployment in Microsoft Azure. Because of Server Ready, we have internally booted Windows Server on the Ampere Altra, Marvel Thunder X, Fujitsu NSP, as well as other ARM server systems. We've been working very closely with Marvell to bring up Thunder X2 for internal deployment. Today, we are using Windows Server on ARM64 for exploring Microsoft internal storage and VM hosting services. As you can see, Microsoft is deeply committed to driving platform innovation from PC to IoT to our public cloud. I want to close by taking a moment to discuss the developer ecosystem. While Microsoft continues to make investments to ensure Windows on ARM systems can run just about any existing Win32 application out there, it is still critical that developers can build and test native software that can harness the true potential of the platform. In pursuit of this goal, we have made significant investments at the core operating system level. Today, Windows on ARM supports both the Windows subsystem for Linux, which gives developers native access to Linux tools and applications on a distribution of their choice, and Microsoft Hyper-V, which is essential for the developer inter-test loop. On the IDE front, Microsoft Visual Studio has been the most popular choice among developers, and Visual Studio 2017 15.9 and Visual Studio 2019 support building for the ARM64 architecture. In addition, Visual Studio Code, which is a lightweight IDE, has been ported to run natively on the ARM64 platform. And if you prefer open source tools to build for Windows on ARM, LLVM is also supported. In addition to tools, it's very important to bring the ecosystem of open source libraries and frameworks to ARM64 so that our developers can focus on building exciting new applications without getting blocked on framework availability. To that end, we have worked with the ecosystem to port Chromium, the Chromium Embedded Framework, or CEF, Electron, V8, OpenJDK, and many other open source frameworks to Windows on ARM. From our experience and talking to many developers over the years, writing software for ARM devices is like writing software for any other architecture out there, and the vast majority of existing 64-bit ready applications can easily be ported to ARM by simply changing the build architecture. There's a session later in the conference by Mark Sweetgall from Microsoft to tell you more about how to use these tools to build great software for Windows on ARM. And with that, I'd like to thank you all for joining me today as we have reaffirmed Microsoft's ongoing commitment to build the operating system and developer platform to enable the ARM ecosystem across the intelligent edge and the intelligent cloud. Thank you.